So first step is to make sure that you are connecting the circuit in proper order. So always try to connect the positive of the circuit with the as shown in the circuit diagram. Remember that the ampere will be connected, positive side of the ampere will be connected with the positive end of the battery, and when you are connecting the galvanometer, the order should be reversed. So the positive end of the galvanometer will be connected to the negative end of the ammeter, and negative end of the galvanometer will be connected to the positive end of the galvanometer. So this is you have to make sure. Before constructing the circuit, once your circuit is constructed, you have to make sure that your key is open. So this is the key, as you can see, the key is open now, and once you are switching on the circuit, make sure your key is open. Now once your key is closed, you will see that there is a deflection in the circuit. So ammeter and voltmeter both are showing some deflection. Now you have to change the current and take recordings. Now this recording can change based on your college experiment setup available. Now you have to make sure that for first experiment, that is resistance per unit length, you have to take 3 different readings. Now how can you take 3 different readings? For example, in this setup I am taking readings for 100 milliampere. You have to change the current and correspondingly you have to note the voltage. You should not change the voltage, you have to change the current and measure the respective voltage. Now when you are taking the current, say 100 milliampere, here I am getting the current around voltage around so remember that in this voltmeter also we have 0 to 0.5, then 1. So basically between 0 to 1 I have 20 divisions, right. So each division is basically 0.05 volt. So each division here is 0.05 volt. So what you have to be careful about, so 0.05 multiplied by the number of division you can see. So 1, 2, 3, 4, 5, almost 5. So it will be 0.25 volt. So your reading will be 0.25 volt for 100 milliampere, right. So take that measurement and then you proceed to the next current, which is 200 milliampere. Slowly change the current to 200, and once you have reached the 200 milliampere, you will see that the voltmeter also have moved. So now you see that the voltmeter is now moved to around 5, 6, 7, almost at 7, between 7 and 8, and do not, if the reading is coming between 2 scales, try to take the closest possible value. So here it is almost at 8. So I am taking 8 means 0.4 volt. So 0.4 volt will be the reading for the second part. Now again you change the current to around 300 milliampere. Now after 300 milliampere the sensitivity increases, so you should keep it where it is steady. So when the reading is at 300 volt, 300 milliampere, you are getting around 0.55 volt. So take these readings, and once your reading is done, you have to calculate it from the table and average, taking the average and calculate the resistance, and then you have to divide the resistance with the given length. The length of the wire will be provided to you, the diameter of the wire will also be provided to you. Now make sure that when you are taking the reading, you have to look directly, not from sides, otherwise there will be an parallax error. So try to avoid it, look directly from the top as much as possible so that your reading is perfect. Now, so once your calculation is done, you have to show the calculations as well, and because the first experiment you do not need to draw any graph, so you can record 3 different values and calculate the mean resistance from each calculation, and don't forget to sign your recordings through the invigilator. At least one of the readings should be signed by the invigilator.